Imagine a world without cars, trains, or ships powered by engines. A time when the rhythm of life was dictated by the natural elements around us. This was the reality for much of human history, where communities thrived or struggled based on the whims of nature. Before the steam engine, people relied on the unpredictable forces of nature for power. Windmills, for instance, were a common sight in many regions. Windmills harnessed the wind, but only when it blew. Their operation was at the mercy of the weather, making them unreliable at times. Water wheels depended on flowing water, limiting their use to specific locations. They were essential for grinding grain and other tasks. Human and animal labor filled the gaps, but their power was limited. Fields were plowed by oxen and horses, and heavy loads were carried by hand. This reliance on natural forces restricted human progress. The pace of life was slow, and advancements were hard-won. Transportation was slow and unreliable. Journeys that take hours today could take days or even weeks back then. Industrial production was limited in scale and efficiency. Workshops were small and output was minimal compared to modern standards. The invention of the steam engine would dramatically change this reality, ushering in a new era of human history. It marked the beginning of the Industrial Revolution, transforming societies forever. The story of the steam engine begins long before its practical applications, tracing back to the curiosity and ingenuity of ancient civilizations. Ancient civilizations observed the power of steam, marveling at its potential to move objects and generate force. They experimented with its potential uses, laying the groundwork for future innovations. One notable example is the aeolipile, invented by Hero of Alexandria around the 1st century AD. This early steam engine was a pioneering step in understanding steam power. The aeolipile was a simple yet ingenious device. It consisted of a hollow sphere with two opposing nozzles, designed to harness the force of steam. The sphere was connected by pipes to a cauldron of boiling water, creating a continuous flow of steam. As the steam flowed into the sphere, it escaped through the nozzles, causing the sphere to spin rapidly, demonstrating rotational motion. The aeolipile demonstrated the potential energy of steam, showcasing its ability to convert thermal energy into mechanical motion. However, it was seen primarily as a novelty, a fascinating toy rather than a practical tool, and its true potential wouldn't be realized until much later in history. Centuries passed before significant progress was made in harnessing steam power. In the late 17th century, English inventors took on the challenge. Thomas Savory patented the first crude steam pump in 1698. This engine, while inefficient and prone to explosions, represented a crucial step forward. It demonstrated the possibility of using steam to do work, specifically to pump water from flooded mines. Thomas Newcomen improved upon Savory's design in 1712 with his atmospheric engine. Newcomen's engine was more powerful and reliable than Savory's. It quickly found use in coal mines across England, where it helped to increase coal production. While Newcomen's engine was a significant advancement, it was still inefficient. It wasted a considerable amount of steam, limiting its power and applications. James Watt, a Scottish inventor and engineer, revolutionized the steam engine in the late 18th century. In 1765, Watt made a critical improvement to Newcomen's design. He added a separate condenser, which significantly increased the engine's efficiency. Watt's improved steam engine used less fuel and produced more power. This breakthrough paved the way for wider applications of steam power. Factories could now operate machinery with steam engines. This led to increased production and the growth of industrial centers. Watt's invention was a key catalyst for the Industrial Revolution. It transformed societies around the world. The impact of Watt's innovation was profound, as it not only enhanced industrial productivity, but also spurred technological advancements in various fields. Steam power became the driving force behind transportation, leading to the development of steamships and locomotives. This revolution in steam technology marked the beginning of a new era, where human ingenuity and mechanical prowess combined to shape the modern world. Watt's legacy lives on, as his contributions laid the foundation for the technological progress that continues to this day. The steam engine's impact extended beyond factories and mines. It revolutionized transportation on land. In the early 19th century, inventors experimented with using steam engines to power vehicles. Richard Trevithick, a British engineer, built the first steam locomotive in 1804. While Trevithick's locomotive was rudimentary, it proved that steam could move heavy loads across land. George Stephenson, another British engineer, advanced steam locomotion significantly. His locomotive, the Rocket, won a competition in 1829. The Rocket demonstrated the potential of steam-powered locomotives for passenger transport. This ushered in the age of railroads. Section 6. Full steam ahead, transforming maritime travel and global trade. The steam engine not only conquered land, but also revolutionized sea travel. Early steamships, like the Clermont built by Robert Fulton in 1807, were slow and unreliable. However, advancements in steam engine technology led to larger, faster, and more efficient ships. These steamships transformed maritime travel. They were no longer at the mercy of wind and currents. They could travel faster and more reliably, connecting distant parts of the world. This led to a boom in global trade. Goods and people could be transported across oceans in a fraction of the time it previously took. Section 7. Powering progress. The steam engine's impact on industry. The steam engine's impact on industry was profound. It powered factories, mills, and mines, transforming the way goods were produced. Before the steam engine, factories relied on water wheels for power. This limited their location and output. The steam engine freed factories from their dependence on water. They could be built anywhere with access to fuel. This led to the growth of large-scale factories and mass production. The steam engine powered textile mills, ironworks, and other industries, driving the Industrial Revolution and shaping the modern world. Section 8. From steam to electricity, a legacy of power generation. The steam engine's legacy extends beyond its direct applications in transportation and industry. It played a crucial role in the development of electricity generation. In the late 19th century, engineers realized they could use steam engines to turn generators. These generators produced electricity. This led to the development of the first power plants. These plants used steam turbines, a more efficient type of steam engine, to generate electricity on a large scale. Steam turbines remain a vital part of electricity generation today. They power countless homes, businesses, and industries around the world. Section 9. The enduring legacy, steam's continued relevance in the modern world. While the steam engine may seem like a relic of the past, its legacy endures. Steam turbines continue to play a crucial role in electricity generation, particularly in power plants that use coal, nuclear, or geothermal energy. The principles behind the steam engine also find applications in various fields. From geothermal power plants to modern transportation systems, the steam engine's influence can be seen in technologies that shape our world. Its story is a testament to human ingenuity and its power to transform our lives.